there, the gun alignment coils are correctly when the electron gun and the aperture are completely in line. If you change any of the aperture and you don't know, you are not following the proper procedure and you lose the beam here and you can't then correct it. You will have to bring some very expert person to align the machine for you. Because if you look into all these things, you have to deal with all these knobs. There are knobs for these, there are gonimeters for these. So you are just like you are sitting in an aeroplane, and aeroplane is also very, very simple in comparison to this. You are doing tilting with your feet. Under the table, you are tilting the sample, translating the sample with your feet. You are dealing with the condenser lens and the condenser aperture. You are dealing with the objective lens and the objective aperture. You are dealing with the alignment of gun and the gun tilting and fixing. Then, when you come from there, then condenser 1. Then after that, you have a fixed aperture that again excludes the unwanted rays and allow only the wanted ones into the second condenser, and in between there is condenser stigmator. So objective stigmators, condenser stigmators are all, because when stigmatism is there, it is not dealing with huge things, so that in whatever shape they are, you will be able to see them. If the stigmatism is diffusing the image, confusing the image by 1 nanometer, and the crystal size is 1 angstrom, so how many crystals you lost became invisible to you. Stigmatism is basically blurring, right? So when the image is blurred and that blurring mixes 1 nanometer area, then you can't see any crystal which is below 1 nanometer, because every edge and every piece is blurred by that amount. And that is why stigmatic characters are very, very important, and each lens has its own stigmators. And stigmators are 2 knobs on both sides, and you are correcting from both sides, the condenser, the objective, and all the stigmators. Then again the condenser aperture there. If this aperture is misaligned, then you will not see any beam here. So the alignment is very, very important. And then the deflector coils, focus wobbler, so that you move the beam and it is not defocused. And that is a wobbler type thing. When you press it, then the beam shifts along the screen. And if that shifting displaces the beam, then it is not, the wobbler focus is not in proper place. The machine is not focused. When you come from there, then you come to the objective lens, then objective aperture, then objective stigmator, and then intermediate lens, intermediate diffraction aperture, and projector lens, and this screen. These apertures are playing the most important role after the lenses in the machine. Because if the aperture is not there, and I told you in my previous lectures that I have 2 crystals here like this, and I'm taking the diffraction pattern from them. So from these 2, I will see spots like this. So a diffraction pattern of this shape is of no use. When I select the aperture so that only diffraction spots from this are allowed to go onto the screen, then here I will get the proper single crystal diffraction pattern, and I will be able to measure R1, R2, R3 and so on, and I have taught you how they are converted into interplanar spacing. So the value of the aperture is equally important. If the aperture is not there, then you can't distinguish between nearby lying crystals. Secondly, when you are interested in composition analysis, the electron beam is coming across the sample, and the contribution from the whole sample is coming, and you are not interested in whole sample. You are interested in the composition or diffraction pattern of a single crystal. That is why you are using the transmission electron microscope. Then for that purpose, you fix the aperture in such a way that in image as well as in the diffraction pattern, the rays are projected which are required. Now, total magnification is basically, NTM is the combination of the magnification from the objective lens times the magnification of the intermediate lens times the magnification of the projector lens, each of which is capable of approximately 100 times magnification. And when you, as many as lenses you include, and you can control, because only inclusion of lenses is not important, their controlling is equally important, so they are not confusing or adding additional flaws into the process of the image and diffraction pattern, then you get that magnification. Here, the objective lens, it focuses the image and diffraction focus as well. It at low magnification, right? At high and low. So by this slide, I mean that the same lens does one type of job at one magnification, but at another magnification, it does a different job, right? So the diffraction lens is a diffraction focus and image focus. So the diffraction lens, as I told you, they are electromagnetic lenses. They are not ordinary glassy lenses. And you have knobs to increase or decrease current in that particular coil. You have a knob on the panel of the machine, and by increasing or decreasing the current in the coil, the electromagnetic field changes there. And that focuses the diffraction spot. The diffraction spot will appear like this, but this is a confusion, because if this is 12 millimeters, say, and instead of this I take here as the center, then it will be 12.3 or something like that millimeter. So 0.3 millimeter in angstrom means 0.3 and to 10 power minus 6 or 7, right? 0.3 and to 10 power 7, right? When you multiply 0.3 with 10 power 7, it will be the number of angstroms, right? Millimeter. So millimeter is already 10 power minus 3. So the angstrom will become 10 power 7. So 0.3 millimeter into 10 power 7 is only this area. So this type of spot is not informative for me. It is not correct, and I will have to have spots like this, so that I can measure it from the center of this part to the center of this part, and it looks also professional. If I have distorted spots like this, they are not professional. I need professional microscopy and professional diffraction. So I start from the center of this to the center of this and measure this. And for that purpose, you turn the knob in both direction and on both sides so that the coil, which is the lens which focuses the diffraction pattern, is brought to the optimum position so that the spots are spherical completely, and secondly they are visible, and thirdly they are not that much bright to burn the screen of the microscope. So if a spot is very intense, then it can burn the screen of the microscope. It is electron beam, and when it is so intense it creates heat, and that heat burns the screen. So you are keeping a compromise between the brightness, the intensity, and the geometry of the spots there. So the diffraction lens is basically at high magnification it focuses the diffraction pattern, and at low magnification it focuses the image. Objective aperture contrast forming. Contrast forming. Contrast means the variation in the brightness or darkness. Please remember that when you are talking of electron microscopy, never talk of colors. They are not color imaging. There is no coloring in those imaging. It is giving you the contrast, and contrast is bright or dark, not white and black. White and black are colors, and bright and dark and gray, these are contrast. So if something is too black, then you can't see the features within that black image. So you decrease the contrast to a gray level, right? So when it becomes gray, then you see the features within that image as well. And when it is bright, this means 100% bright means that the beam has completely transmitted and it has not interacted with the sample. So the brightness comes from the transmitted beam, and the dark and gray regions come because of the diffracted beams. Selected area electron diffraction aperture, it is called. Usually you will see in papers SADP, SAED, SAED, selected area electron, no, S, selected area electron diffraction, SAD. SADP, selected area diffraction aperture. SADP, selected area diffraction aperture, and I explained to you that if that selected area is not there, then the spots from different crystals are coming, and you can't properly say that from which crystal these spots are coming. And they are so confusing that there is no symmetry and no geometry proper in those spots. And that selected area diffraction aperture is used so that all the beams coming are just